This video is for integrated 3. This is on factoring, the notes that we took on Friday. So factoring. And I'm going to go through a couple different types, but the very first thing we always want to do when we are factoring is always see if you can factor something out always see if you can factor something out of every term. If so, you want to factor out the most that you can. So if so, factor out the most that you can. Which we call the greatest common factor. Once you do that, you always want to check to see if you can factor again. Then check to see if you can factor again. Now, assuming that we cannot factor something out. The first type of problem I'm going to go through is going to be an example with what I call a diamond problem. So you can use a diamond problem or the idea of a diamond problem when you're trying to factor something like x squared plus bx plus c, where your lead coefficient in front of your x squared is a 1. So I'm going to go through 2 examples like this. So the first example, let's say we have x squared minus 7x plus 10. So in this situation, what you want to do is you're going to make a diamond, and the constant, okay, that 10, that positive 10, is going to go as your product. Okay, you want to figure out what multiplies to 10. The x, okay, which is this negative 7x, is what you are trying to add or combine to. Okay, so we're trying to add and get a negative 7. So when we're trying to figure out what multiplies to a positive 10 and adds to a negative 7, that is going to be a negative 5 and a negative 2. So our answer is going to be x minus 5 times x minus 2. And that is our factors. Do one more like this. Let's say that we have x squared plus 3x minus 10. Again, I'm going to look at the constant, okay, which is a negative 10, and that is going to be my product. And I'm going to look at the 3x, it's positive 3. So I need it to add to a positive 3. Now, in the first problem, I'm just going to highlight this in yellow for a second. This was a positive 10, okay? And that means that both of the numbers are going to be either both negatives or both positive, which means we're combining to get that 7. We're adding to get that 7. In this situation where we have a negative product, both of the signs are going to be different. So I'm really subtracting to get a 3. Okay. So when I'm doing this, I'm asking myself, what multiplies to negative 10 and adds to a positive 3? And that's going to be a positive 5 and a negative 2. The 5 has to be positive because the sum was positive, so the bigger number has to be positive. And our factors are going to be x plus 5 times x minus 2. Now, the next type of problem I'm going to go through is what I'm going to call box to diamond. Okay. So for this one, when I'm talking box to diamond, this is where I have a coefficient in front. So let's say I have an ax squared plus a bx plus c. So an example of this one, let's say we have 2x squared plus 11x plus 12. So what I'm going to do is I'm going to do a box. And I am going to put my 2x squared in either the top left box or the bottom left box. Okay, so I'm going to put this 2x squared right here. Then I'm going to take my constant. Okay, I'm going to take this 12 and I'm going to put it here. So I'm going to have a positive 12 here. What happens is when we do these problems, we saw this in integrated 2, this multiplies to a 24x squared. The pattern is also that this other diagonal also multiplies to a 24x squared. So what I'm going to do is I'm going to end up with a diamond where I have a 24x squared as my product, and my sum, let me just get rid of these diagonals for a second. My sum is going to be this 11x. Okay, so this box and this box have to together add to 11x, but they also need to multiply to that 24x squared. Okay, so when I'm doing that and I'm trying to figure out what multiplies to a 24x squared and adds to 11x, that's going to be an 8x and a 3x. So it doesn't matter. One of these is going to be 8x, one of them is going to be 3x. Now, when I'm doing this, I always focus on my x squared box. So what goes outside of my x squared box? So x squared, it's going to be a 2x and an x. So I'm going to put my 2x here because that's going to help get the 8x. And then I'm going to put my x here because that's going to help get the 3x. So 2x times 4, a positive 4 gets us 8x. And x times 3 gets us 3x. So our factors are 2x plus 3 times x plus 4. That is box to diamond. Now, the next two I'm going to talk about are special quadratics. So one of the ones I'm going to talk about is going to be a difference of two squares. So difference of two squares. And the formula for that is a squared minus b squared, where I have a square minus a square. That's where the term difference, because it's a minus, of two squares. I'm subtracting two squares. And what happens is I get two binomials. One's going to be a plus b. One of them is going to be a minus b. What happens is because I have a plus b and a minus b, I'm going to end up having my middle term cancel out because one time it's going to be positive, one time it's going to be negative. So for this, let's say, for example, I have a 9x squared minus 16. Okay, now 9x squared, I'm going to take the square root of 9x squared, which is going to be a 3x. I'm going to take the square root of the 16, which is going to be a 4. So my factors are going to be 3x plus 4 and 3x minus 4. That is going to be my answer. Now, just as an example, if I was to multiply this back, I need to get my 9x squared plus 16. So I'm just showing you, you don't have to do this as part of the problem. But if I have a 3x plus 4 and a 3x minus 4, I get a 9x squared I get a positive 12x, I get a negative 12x, which means those are going to cancel. That's why I don't have a middle term with an x in my original problem. And then I get a negative 16. So you see I got 9x squared minus 16. That's why I need one of these to be a plus and one of these to be a minus, but they are the same two terms in both parentheses. The plus and the minus are going to make that middle term cancel out. Okay, the next one is going to be a perfect square trinomial. Let me just add a page onto this. So perfect square trinomial. Now, for the perfect square trinomial, it could be one that's like my diamond problems where I could use a diamond. It might be ones like the ones where I have to do a box diamond. But if you see the formula and you recognize it, it just makes your math easier, faster. So one formula is where I have a squared plus 2ab plus b squared. So what you're looking for is to have a square in the front and the back. Maybe that's the key word here. Maybe it's a perfect square. And so I would take the square root of my a squared, which is a. I'd have a plus because there was a plus in front of my 2ab. I'd take the square root of b squared, which is b. Now I would want to check to make sure that I get this 2ab. So the pattern here is that if I multiply these together, which is ab, and then I double that 2ab, you see I got that. We always want to check that, okay? Because there's a lot of trinomials that have an a squared and a b squared, or squares in the front and the back, but maybe are not perfect square trinomials. So you want to be careful. So then I have a squared minus 2ab plus b squared, which is the same situation. Again, I happen to have a square in the front, I happen to have a positive plus square in the back. And this is going to be the same thing, but this time it's going to be an a minus b squared. It's just helpful if you can recognize these and do these quickly. So I'm going to go through two examples of this. So let's say the first one, we have x squared plus 18x plus 81. So you'll notice that I have a square here and I have a square here. So maybe it's a perfect square trinomial. So if I take the square root of x squared, I get an x plus, because there's a plus in front of my 18x. I take the square root of 81, which is a 9. So maybe it's x plus 9 squared. So again, you always want to check. I'm going to check here and then I'm going to erase it. If I multiply this together, I get a 9x. If I double that, okay, remember 2ab needs to be there, I get an 18x, which is what I have here. So this was a perfect square. And you always want to check to make sure you get that middle. Okay. So let's say I have another example. So that first example, I could have really used a diamond. But if you recognize as a perfect square trinomial, it's just a little faster. Now this next one, I could use a box to diamond, 9x squared plus 42x plus 49, but that's going to be 9 times 49. I'm going to get a big number that I have to deal with. But if I recognize that, hey, looks like there's a square here, and the square root of that would be 3x, and I'm going to put a plus because there's a plus in front of my 42. And then the back happens to be a square. 49 is a 7. So I'm going to go plus 7 squared. Remember, we need to check to make sure we get this middle 42x. So I would multiply these together, which is a 21x. And I would times that by 2, which is a 42x. And you see I got that 42x. So it was a perfect square. And that's my answer. Now, the last type is called the sum and difference of two cubes. So let me just write this out first. So this is going to be the sum or difference of two cubes. And we have two formulas, one for the sum, one if it's a difference. So if I have a cube plus a cube, so a cubed plus b cubed, I am going to take the cube root of my a cubed, which is a, plus, because it's a plus right here. And I am going to take the, sorry, I was trying to get rid of this. I'm going to take the cube root of b cubed, which is a b. Okay, that's my binomial. Then what I do is I focus on this binomial, that a and b. I square the first term, this a, which is an a squared. My sign here is going to always be opposite. So since this was a positive, this is going to be a negative every single time. Okay. And then what I'm going to do is I'm going to multiply these together, which is an AB. Okay. Then I square the last term, which is a b squared. And that's my answer. That is my answer. If I have a cubed minus b cubed, it's going to be the same idea. I take the cube root of a cubed, which is a, minus, because it's a minus here, I take the cube root of b cubed, which is b. And then again, I'm focusing on this. So I square this a squared, this a, which is an a squared. I look at this sign, which is a minus, and this becomes opposite. This becomes a plus. Then I'm going to multiply these together, a and b, so I get an AB. And then I'm going to square that negative b, which means I'm going to get a b squared. And that is my answer. So let me go through one example like this. So let's say we have a 27x cubed minus 64. Okay, so I'm just going to jot this here. I am going to take the cube root of 27x cubed, which is going to be a 3x. So this was really a 3x cubed. I am also going to take the cube root of 64, and the cube root of 64 is 4. So this was really a 4 cubed. So this is really like my A, and this is really like my B. So my answer is going to be 3x minus 4, because that's the cube roots of each of those terms. That's my binomial times. And now I'm going to take this 3x and I'm going to square it, which is a 9x squared. I am going to look at this minus, and now this is going to become opposite, which is a plus. And then I'm going to square this negative 4. Sorry, I'm going to multiply these together. Sorry, I'm going a little ahead. I'm going to multiply these together. So let me just do that. I'm going to multiply these together, which is going to be a 12x. Then I'm going to square my negative 4, which is in 16. And that is my answer. That binomial times trinomial. And that's the end of these notes.